before my interview. Haven't really done too much prep. I think I'm kind of cooked, but fuck. Don't think I'll spend any more time on C++ stuff. Probably should have done that more at work. Man. Okay, let me just try this math question first. Plus, I guess. Oh, okay, great. Pencil. Full screen this. I can open a new window. So, let me just do this. Try. Okay, that's right here. So we want the expected value, the distance between 2 points uniformly in 0, 1. So the probability, so let's define can I make this thicker? I mean thinner? So let's have z, a random variable z. So basically, the probability of x and y is going to be so for just a random variable in 0 to 1, probability of x like L less than equal okay, so the probability of x being less than equal to a range, assume L is less than equal to R. Sorry, except assume LR is in the interval 0, 1. Otherwise, you just clamp it to 0, 1, or just set it to 0 after not. If they don't include anything in 0, 1, it's going to be L minus L. So, because x and y, let's call the random variables x and y, the points, then the probability density function of x is how did I forget this? X and y are independent, then it's going to be the integral from 0 to 1. It's going to be integral from 0 to 1. I should maybe try and read this would be easier. It's going to be, sure, yeah, stroke with, sure. Should we solve this? It's going to be the integral from 0 to 1, integral from 0 to 1, y minus x. Let's just do x minus, it doesn't really matter. X minus y dy dx. Times the probability of x, y. How the fuck did I forget this? Probability density function. It's just gonna be 1, 0, 0 less than equal to x less than equal to 1. Otherwise, it's gonna be this dy dx dy. This density will always be equal to 1. So I can get rid of this. This is just going to be an integral 0 to 1, 0 to 1, x. So I'm actually going to do it like this, because this is actually going to be the same as this. We can utilize symmetry to do something like this. dy dx. X. And then you can just evaluate this. We can actually split this up to 2 times 0, 1. Oh my god, how did I forget all this stuff, bro? It's just easy, man. Surely coworker. Prep. Let me just share this with my laptop so my OBS can get this. Oh my god, I am so cooked. D-shop prep. PDF of x. The probability of x is just 1, 0. If 0 is less than x equals 1, otherwise, so probability of x and y is actually just going to be px, py, because x, y independent. Otherwise, so expected value of this variable z is just going to be equal to the absolute value of 1 minus x. X minus y doesn't matter. Expected value of z is going to be expected value. What just wrote this. X minus y. This is going to be, by definition, the integral over sample space of probability dc vector z x. We just define a random variable like this, dz. We can just take this as the two iterator integrals, pxy z1, sorry, x minus y, because this is continuous. This function is all continuous. Dx dy. This is going to be 1 for all of this. X minus y dx dy. Can utilize symmetry here to have x less than y. Have this. Now we can just utilize so we can integrate this. This is going to be xy minus y squared over 2, evaluate at 1, 0. Sorry, x0 dx is going to be 2 times 0, 1. X squared minus x squared over 2 dx. This is just going to be the integral 0, 1 x squared over 2, which is going to give us 2 1, which is raw. Did I forget probability theory? How would I fuck up this badly? Could have easily done this in my stats days, man. Okay. Maybe the 2 wasn't feasible. 1. It's going to be x squared. Probability of L is going to be 1 minus this. How did I get this so wrong? Expected value of x minus y. It's It's going to be integral of 0, 1. 0, 1. Probability of x and y. X minus 1, right? This is going to be 1 because probability of x the density is going to be 1. Density is always 1. dy dx. Is my integration wrong? Integration wrong. Split this into 2 integrals. This would be equal to, I'm just going to integrate this first. So x squared, sorry, xy squared evaluated at x0. dy dx. This would also be y for 2 minus x y evaluated at 1 minus x. You can just compute this easily. So this is x squared minus x squared over 2. X plus 0, 1. So this would be half minus x minus plug in x squared over 2 x. We can just finish this. These two are actually going to cancel out, and they're going to be left with 1/2 minus x. What the fuck is wrong? Oh my god. That is not how integration works, bro. I am actually so fucking retarded. Okay, so this That's such a stupid mistake. Just forgot to fucking integrate, man. Okay. Sure. Whatever. Go back to this step. This is gonna be 2 integral 0 1 x squared over 2 dx. This is equal to 2 x cubed over 6. Value at 1 0. It's gonna be 2 times the 6 is the third. She's so cooked. Price distance. Sequence. Pissed off. Next one, just fashion. You have a sequence of prices and the expected price difference between two adjacent zero. So we're given. I need to turn this in here. So you're saying we have, for example, x1 to xn. This is a sequence of prices, and then we have the expected value. So xi minus xi plus 1 is going to be equal to 0. When you okay. So the expected value is going to be normally distributed. Is sigma squared. Let's call this S. You want to figure out the variance of an error. Observe a price. What? So you're saying we also have y1, yn, where yi is normally distributed. Xi is normally distributed of 0. So every variance equals v2 then. So it's the same as saying normally distributed xiv. So I want to find vi actually. It's going to be vi. Actually, I guess this whoever wrote this question actually did not. You want to figure out the variance of the error and the variance of the price difference. Okay. So I want to figure out S and V. If you want to figure out S, so these are actually unknown. This is known. Yi's are known. Yi's can be samples. Sample from S. Some other variance. I need to pull this. Holy shit, these questions are. Perfect, it's just not working. Very great. Alright, so let's see this. So we have x1, we have random variables. These are our prices. Now we have that expected value of xi minus xi. Sorry, the expected difference. Price difference has a distribution of 0s squared. Or 0s maybe. So given the I think it's not working. No, great. So let me stop sharing, share it again. My iPad's Wi-Fi is actually so bad. Please just connect, man. Okay, there we go. Expected value. We also have y1, yn, and we're saying that the expected value observation error is, so it's going to be xi with some variance v, and this v is common, so we want to estimate v and s. Okay, put out v first. Let's see, v. V. We don't have x. Don't know this. We don't know x. I'm trying to figure v out. Why Oh, okay. Actually, we can probably do both at the same time. For each I from 1 to n, sample yi n times. We're gonna estimate. Oh my god, what the fuck is wrong with this? How's it working well, man? This is actually not connecting. Cool. Come on. Okay. We can estimate yi. We can estimate xi to be roughly the mean. To be roughly the mean. Then we want to estimate variance. Estimated variance. So we have that the variance of x is equal to expected value of x squared minus x squared. Expected variance probably. If it's a common variance, then what we? If it's a common variance, call this xi. Actually gonna have one ij. Estimate the variance of v. Then e, then to estimate s. this minus the mean. Well, the mean's gonna be 0, so it's just gonna be this. I needed to have started studying so much sooner. So much sooner. I'm actually so fucking cooked. Math is actually generated. God, it's 10 p.m. Fucking hell. Oh my god, I'm gonna keep grinding this tomorrow. Oh, fuck. I'm actually so cooked.